Hello everyone, welcome back with another session on my YouTube channel. In the today's session, we are going to discuss about the Bitwise operators and their working. But in particular, I'm going to talk about the Bitwise AND operator, Bitwise OR operator, Bitwise XOR and Bitwise NOT operator. So let us quick start our session. First of all, let's have a look at what is a Bitwise operator. So here you can see that the name of operator that we are talking about is bitwise. Bitwise means that it is going to perform some operations bit by bit. That's why the name is bitwise operator, right? So the first point is the bitwise operators, they operate directly on the bits of the binary digits, right? Or you can say bits of an integer number, okay? Then the second point is each of these operators, they are going to perform their operations on each bit of the operands or the data values. For an instance, let us say you have the two 4-bit binary numbers where the first number is 1010 and the second 4-bit binary number is 1110, right? So here, how many bits you are having in each number? There are 4 bits. So as the name suggests, bitwise operator, so it means that the bitwise operator, any operator you are going to operate either on the two numbers or on single number, right? It is going to operate on that particular number bit by bit, right? For an instance over here, if we talk about these two 4-bit binary numbers, right? Then how bitwise operator is going to perform is, first of all, it is going to compare the rightmost bit of the first number with the rightmost bit of the second number. Then after this, in parallel, it will compare the second bit of the first number with the second bit of the second number. Then the third bit will be compared, then the fourth bit will be compared, and so on. So this is what we mean by bit, right? But in contrast, don't get confused with the logical operators that we have. The logical operators, they actually work on the logical expressions. For example, you have two conditions. For example, if you want to check whether the particular number is the greatest number, so you will say if A is greater than B and A is greater than C, it means A is the greatest, right? So basically here you are using logical AND operator, okay? But if you want to operate on the bits, then for that purpose, we'll be going to use the bitwise operator, right? Okay, so actually I'm sitting in the ground over here and one airplane is passing. Okay, so these are the bitwise operators that we have. So the 6 bitwise operators that we have in total, but in today's session, we are going to discuss about only the first 4 bitwise operators, which is bitwise AND, bitwise OR, bitwise XOR, and bitwise NOT. The last 2 operator, which is your left shift operator and the right shift operator, will be discussing in the next session, next video. Okay, so let's start with the first operator, which is bitwise AND operator. So bitwise AND means in your +2, you might have learned about the AND operator, which is logical AND, right? Where you know AND operator works only when the 2 inputs are true, only then your final output will be true, right? The same is the case for the bitwise AND operator. When you are comparing the 2 bits, right, and both the 2 bits are 1, only then the result will be 1, okay? So for example, over here, in this case, we take 2 numbers A and B, right, where value of A is 4 and value of B is 5. If you convert this decimal number 4 and 5 into the binary number, then you will get this answer, which is 0100 for the 4 and 0101 for the value 5, right? Now, how we are going to compare is, now see over here, the rightmost bit of number 4 is 0 and rightmost bit of number 5 is 1. So bitwise AND of 0 and 1 will be, what it will be? It will be 0, right? It will not be 1. Okay, because it is the AND operation. You need both bits to be 1 to be true. Similarly, the next 2 bits, they are both 0. So answer will be again 0. Then after, the next 2 bits are 1. So the answer will be 1. So when you find the answer, in the end, the final value will be 0100. This is the result for the bitwise AND operator. Then next one you have is the bitwise OR operator. So what this bitwise OR operator is? So in contrast to the bitwise AND, where you need both the inputs to be true to get the final output value as true. right? In this case, you need only one input value to be true. That's why the name is OR. OR means either this to be true or that to be true. Only then the result will be true. Correct? So here in this case, again, we are taking the same example. In the main function, we are having two integer numbers A and B, right? Where value of A is 4 and B is 5. Okay. And if you perform A or B, what will be the result? So let us see over here, since we know that OR take two numbers as operands and does OR on every bit of two numbers, right? And the result will be 1 if any one of the two bits is 1. So here, when you check the bits, here 0 and 1, 1, 0 and 0, 0, 1 and 1, 1. So the answer will be 101, which is basically your number 5, right? Very simple. Next we have is the bitwise XOR operator. Now, what is bitwise XOR operator? Again, the most important operator that you have under the bitwise category. And this operator, you know what? It has one application. You might be aware of the security algorithms, right? In the security algorithms, your bitwise XOR operator is implemented to encrypt your data or encrypt the text, right? So what is the principal rule of the bitwise XOR is, in contrast to the bitwise AND and bitwise OR, it will produce the true value only when the two bits are different. Yes, only when the two bits are different. So result of XOR is 1 only if the two bits are different. For example, 0, 1 or 1, 0. But if both the bits are same, for example, 0, 0 or 1, 1, then you're going to get the result as false, right? And the symbol for the bitwise XOR is this cap symbol, right? Next you have is the bitwise not operator. But before bitwise not operator, let's see another example of the bitwise XOR. Now let's see over here. If you have both the numbers as same, then what will the result of the bitwise XOR? It will be 0. Why? Because both the bits will be same. For both the numbers, for example, here A is also 5, B is also 5. And since the binary representation is going to be the same, so it means that in this case, your final value is going to be 0. Right? It means you can use a bitwise XOR operator over here to check whether two numbers are equal or not. Okay. Right. Next you have is the bitwise not operator. So what the bitwise not operator is? Bitwise not basically means not means complement, reverse, right? So here the bitwise not operator, unlike your XOR and an OR, which are the binary operators, bitwise not operator will work only on the one operand, which is one data value. Okay. For example, if you write minus a, so minus a is going to convert your positive number into the negative number, right? It means it's a unary operator. Similarly, over here, your bitwise not is also a unary operator, right? And how it is going to work is, it will convert your 0 to 1 and 1 to 0. Okay. For example, you have the binary, you have the decimal number as 103, and you convert into binary, you will get this value, which is 11001111. And if you convert it, you perform the reverse of the bits, 0 to 1, 1 to 0, you will get the answer as minus 104. Okay. And the same will be for other numbers also. And if you want to create the formula will be bitwise not of any number n will be equal to minus n plus 1. Okay. For example, if n is 5, then bitwise not of 5 will be minus 6. Okay. I don't need any calculations either for the same, right? So this was about the bitwise not operator, and you can check it. For example, here the value of A is 10, and you say B is equal to not of my complementary bitwise not of A. Then what is your result over here? You get value of B as minus 11, right? So that's it for the bitwise AND operator, OR operator, right? And XOR operator also. I hope you understand all the lecture. And let's summarize your lecture also. So we discussed the following points. Okay, we are coming back, but we need to move forward. Right. So next, we are going to now summarize. So if I summarize, then we will get the following points. Bitwise operators are the operators which work on the bits of an integer numbers, right? However, you need to make sure that applying bitwise operators on negative numbers will produce the undesired result. So you need to make sure जो आपका right side का operand है, right side data value, it should not be a negative number. Bitwise AND operator will produce true value only and only if both the bits are true, or will produce true value only if any one bit is true, right? And bitwise XOR when both the bits are different. And Bitwise Not Operator will convert true to false and false to true. So that's all about today's lecture. I hope you enjoyed the lecture. If you have any doubts, please post down your comments in the comment section below. Thank you for watching my video. Please do like, comment, share with your friends and subscribe to my channel. Thanks for watching. Thank you so much. Have a good day. Take care.